In this video, we're going to go over what a surjective function is, or a surjection, we say. So we'll start with a definition. We say that a function f that goes from a to b is a surjection. It is a surjection, or you can say it is a surjective function. And that is our condition here. If every element y that is in our codomain, so in our set B, has at least one preimage x that is in A. Okay? What you could say is, using the preimage of a set, you could look at every element in our codomain, so y would be any element in our set B, and this would not be the empty set. Okay? It has at least one preimage, one element. Now you could also write this as I am, so the image of the function, or you remember we can also use the notation the image of the entire function, which is f of the domain A, and that would be the entire codomain. So in terms of Venn diagrams, this is just like multiple ways that you can see or imagine what a surjection would look like. If we have a function f right here and all of our elements in our codomain here, well, every element in our codomain has to have one preimage. We know that this is always the case for every element in our domain. Every element in our domain has to be related to one element in B. What a surjection tells us is that every element in our codomain also has a preimage. So let's go over some examples. As always, for our first example, we're going to start with something trivial, the identity function over a set A. Now I know the identity function is the most boring function you can think of, but it also has, paradoxically, all of the interesting properties that you would want a function to have. So the identity function is a surjection, and that is because every element A has a preimage. Every element of our codomain A has a preimage, which is itself. Now, if you want to be a little more formal about this, you can start with an arbitrary element y that is in A. Then you can write y as being equal to the identity of y. So an arbitrary element of our codomain has a preimage in our domain. And since since y is arbitrary, it works for all the elements of our set. Now, for a more interesting function, we can talk about the absolute value function, which goes from a set of real numbers to the set of non-negative real numbers. And the way we define the absolute value function, it's a piecewise function, which sends x to itself if x is already positive or equal to 0, and we send it to negative x if x is a negative number. So this step right here, this condition right here, ensures us that we're always going to have a positive number. So if we have negative 4, it's going to be sent to minus 4, which is 4. And this gives us our lovely v function like this. It is a surjection because we can start with an arbitrary element in our codomain, which is a non-negative real number, and we can find a preimage of y. Okay, we can write y as being equal to the absolute value of y. An element y right here has a preimage, which is y, but it also has a preimage the other side right here, which is minus y. So we can write y as the absolute value of y or the absolute value of minus y. And this means, I just need to point out that we need at least one preimage. We can have 2, we can have 3, we can have an infinite amount, it doesn't matter. Here we found 2 preimages for our arbitrary element? Well, 2 preimages if it is not 0, because when we have 0, well, 0 and minus 0 are both equal to 0. We'd only have 1 preimage. In any case, for the third example, we can talk about the projection of R2 onto simply the set of real numbers. So we would send a pair xy to simply x. Let me bring that down a little bit. We can take an arbitrary real number x, and we can write this as x is equal to p of the pair x0. We can take x0, we can take x of x and anything. Okay, so x and 1, x and any other real number. You can even take x of x and pi. Really doesn't matter. We have an infinite amount of preimages in this case. So the projection is also a surjection. For our last function, we can take the sine function, which goes from the set of real numbers to the interval -1 to 1, and we send x to your classic sine of x. Remember your classic sine function, which looks a little bit like this. Now you can laugh about how bad I am at drawing the sine function. What I want you to notice here is that it is a surjection when you restrict the function, the codomain of your function, to what it covers. So right here. So it goes from -1 to 1. If I would include the elements that are right here, I can put it in another color. If I would include those elements right here in green, if I would include them in our codomain, it would no longer be a surjection. Okay, the point here that I'm making is that you can always restrict your codomain to become a surjection, or you can always add more elements to your codomain so it's no longer a surjection. In this case, if we take an element y that is in our interval, we can write y as sine of arcsine of y. Now this here, arcsine is the inverse function. It is the inverse function of sine. And there is a certain relationship that we want to investigate. The relationship between inverse functions, the fact that a function is an inverse, and the notion of surjection and injection. So this is something that you can look forward to in future videos. To close this one, let's recall the definition. We say that a function f from a to b is a surjection if every y in b, which is our codomain, has at least one preimage x in y, x in a, which is our domain.